Hello. You can hear me, right? Now you should hear me. Yes. Okay. Thank you for the confirmation. And we're gonna continue with the CodeArts part today. We will gonna build projects and deploy the internet. Before that, we were gonna look the theoric parts of the with the slides. But before the theoric part, if you have any question, you can ask the chat. I will try to answer with my best. If you're not, we can start with the slides presentation. Hi, welcome. Let me share the presentation. Just give me a second. I couldn't find it, sorry. Zeynep AFK açtı gitti. Okay, let's continue with the sharing screen. Okay, okay. Today we will gonna start with the CodeArts service, and these are our contents. Evolution, Devops, CodeArts, and CodeArts services. We're gonna look down. But before that, we will start with the evolution from monolithic to microservice architecture. Let's start with the first one, monolithic architecture. First up, we have monolithic architecture. Think of the as the one big box approach. In this setup, the whole application, the user interface, business logic, or data access are packed into one big program that runs as a single unit. It's easy to start with, but over time it becomes a bit of a pain because any change means redeploying the whole thing. You are also stuck scaling vertically and basically adding more power to the machine. And the second part is we'll start separating the application from the database. This means our application code and data are no longer fighting for the same resources. Now, each can be scaled and optimized separately. This makes things a little more efficient and let us handle more complex stuffs. And the next one is application clusters in a primary standby mode. Here, the primary instance runs the show, and if it ever fails, a standby instance steps in. It's like having a backup plan for emergencies. While this step improves reliability, the standby instances sits idle most of the time, which isn't the best use of resources. And we take it up a notch with load balancing. Now we are running multiple instances of our application at the same time, and the load balancer distributes incoming traffic among them. This way, all instances are working together, handling requests in parallel. It's a great way to improve both scalability and availability. And after that, to handle database loads more effectively, we start isolating read and write databases. Instead of overloading a single database with both routes and write operations, we designed a primary database for writes and create a read replicas to handle the read requests. This approach lightens the load on our primary database and makes it easier to manage growing data demands. And last one in this slide, we have a cache technology. Frequently accessed data is stored in the cache so that we don't have to hit the database every time. Think of it, it as putting sticky notes on your desk for quick access rather than looking up everything in a file cabinet. This setup reduces database load and speeds things up. Of course, if you have any questions, you can stop and ask me. I will try to explain more detailedly. And the next slides, for data that needs to be quickly searchable, say for full text search, we bring in a search engine like Elasticsearch. It's way faster at searching and a regular database. So now users can find what they need in a snap. This is another way we make the application more efficient for specific tasks. After that, at some point, even our database may become too large to handle efficiently. That's when we introduce database sharding. We can shard vertically by splitting up different types of data. For example, user data versus order data, or horizontally by slicing between table, like putting users with certain IDs in different databases. This speeds the data load across multiple databases and let us handle much larger data volumes. For certain types of data that don't fit neatly into a traditional table, we move to no-scale databases. They are flexible, scalable, and great for handling things like user profiles or large-scale data. It's like using a different filling system for documents that don't fit into regular folders. So the next one, to keep services working smoothly together, even when they don't need to respond instantly, we bring in a message-oriented middleware, MOM, like RabbitMQ or Kafka technologies. This allows our services to send and receive messages asynchronously. It's like leaving messages on a whiteboard so others can pick them when they are ready, which keeps things moving smoothly without everyone waiting on each other. Now, We want to make sure users across different locations can access content quickly. This is where nearby access and content decoupling come in. So, by using content delivery networks, it means CDN, and caching, we bring data closer to users, no matter where they are. This cuts down on load times and improves the overall experience for everyone. And the last one, finally, we have microservices architecture. Now we have an application that's broken down into a bunch of smaller independent services, each handling one specific function. These services communicate over APIs and can be scaled, deployed, and updated separately. It's a huge step in flexibility and resilience, allowing us to make quick changes and scale specific parts of the system without affecting the rest. Okay. After the learning the history of the microservice architecture, now we can look at DevOps. Uh, Here is more concise version of the DevOps explanation. Let's talk about DevOps combines like development and operations to make building, testing, and releasing software faster and more reliable. Traditionally, development and operations teams worked separately, which led to delays and miscommunications. But DevOps brings them together, creating a collaborative culture focused on shared goals. So there are some key concepts. First, continuous integration and continuous delivery. So means CI/CD. Code changes are automatically tested and deployed, getting new features to users quickly and safely. And secondly, EIC. We manage infrastructure with codes, making it easy to set up, scale, and replicate environments. And lastly, automations and monitoring. By automating repetitive tasks and monitoring system proactively, DevOps reduces errors and speeds up problem solving. Then let's answer the obvious question: why should we use DevOps? DevOps creates a fast, agile, and reliable approach to software. It's perfect to modern architectures like microservice, where small, independent services need to be deployed and managed efficiently. In short, DevOps helps teams release high-quality software quickly, with everyone working together to deliver best experience for users. And the next, we have waterfall model before DevOps. What's the waterfall model? Let's look at it. In this model, each phase of the project, requirement analysis, design, development, testing, and maintenance flows sequentially from one to the next, like steps of a waterfall. Once a phase is completed, it's difficult to go back and make changes, so planning upfront is essential. This model works best when project requirements are well defined and unlikely to change. However, it's less flexible, and modern approaches like Agile, which can adapt more easily to feedback and evolving needs. So, after that, let's talk about Agile model. Agile is all about flexibility and adapting as you go. Instead of following a strict step-by-step process, Agile breaks the project into small, manageable chunks called sprints. Each sprint produces a working part of the product that we can test, get feedback on, and improve right away. With Agile, teams work closely together, make quick adjustments based on feedback, and keep refining the product. It's perfect for projects where things might change along the way, and it helps teams deliver value to user fast. Then after all these models, we have DevOps. Let's look at what's happened after DevOps. Essentially, things start to move a lot faster and smoother. Teams can release updates more frequently and with fewer hiccups because everyone's on the same page and processes are automated. DevOps doesn't just break down barriers between development and operations. It creates a culture of collaboration where everyone, from developers to testers to operations, work together seamlessly. Uh, Compared to traditional models like waterfall or even agile on its own, DevOps bring some unique advantages, like speed. With automated testing, deployment, and monitoring, updates can be released faster, often multiple times a day, instead of waiting weeks or months. Reliability. CI/CD pipelines catch bugs early and keep code stable, meaning fewer outages and faster recovery times of issues to pop up. Also, flexibility. DevOps work well with microservices, allowing small independent services to be updated without impacting the entire system. And lastly, we can say continuous improvement. Teams learn from every release, incident, and user back, constantly improving the system over time. In short, DevOps enables teams to deliver high-quality software quickly and consistently. It's about working smarter, responding faster to user needs, and keeping the system reliable, making it a game changer in the development world. And in that way, uh, we have CodeArts services in Huawei Cloud for our DevOps applications and project development. Then let's talk about it. CodeArts is a DevSecOps platform that provides a suite of ready-to-use cloud services covering requirement tests, requirements delivery, code commit, code check, code builds, verification, deployment, and release. DevSecOps is a structure based on DevOps with security measures in place. It simplifies deployment by providing end-to-end support. And we have a chart now. Here we see the Collar service chart. We will proceed according to this chart and start building projects. But we will look detailedly on this chart, and you can see requirements at the left part after the user, and we have source codes in the CodeArts repo. After that, we can look the CodeArts check, build, artifact, deploy, and test plan. All these steps are included in the CodeArts pipeline, and we can manage them in the pipeline. Let's look at it step by step. CodeArts requirement is an agile project management and collaboration service for software development teams. It provides efficient, transparent, and visualized project management, requirement management and planning, sprint management and planning, process tracking, bug reports, static report, and storing project documents. And the next one is CodeArts repo. It is the distributed code and version management platform using the Git workflow. It provides functions such as security management, authorization, and permission management. Bench protection and merging online auditing, statistical analysis are doing here. Therefore, it includes code hosting, code review, code trace, continuous integration, where the processes of what kind of changes are made in the code are monitored. It helps business of different sizes to increase the quality and efficiency of their R&D. Repo addresses issues such as collaboration regardless of distance, multi-branch concurrent development, code release management, and security. So the next one is code check. A service deployed by Huawei to improve code quality and security. CodeCheck provides features such as code style and code quality. It can detect bugs, code defects, and performance issues based on the setting we make. That is the tasks we create. In short, CodeArts Check aims to provide two factors and one main goal. The first factor to improve code quality, and the second is to improve the security of the whole project. Let's look at the CodeArts build. It's an easy-to-use build platform that supports multiple software languages, helping you achieve continuous delivery with shorter lead times and higher delivery efficiency. Supports code delivery, code retrieval, build, and packaging with automation and real-time status monitoring. We can create and package tests using popular languages and tools, or we can customize application visualization for multi-language completion. Also, after the building part, we have Artifact. CodeArts Artifact is a software package management service where management is done in a visual and traceable way. Usually created by the source code or packaged from the source code. These software packages can contain information such as name, size, repository address, build tasks, creator, and build time. We said we have two types of repositories. The first one is release repo, where we can see our build results and use them in CodeArts. Deploy section. The second one is self-host repo. Here we can store special component packages about development languages and use them as snapshots in the system. There are also component packages for technologies like Maven and Gradle. In this, there is actually what will be built according to what will be built. Since we can customize these, we can store them privately. CodeArts, let's get CodeArts deploy. CodeArts deploy is a service that enables applications to build on virtual machines and containers. It also supports parallel deployment and seamless integration with the CodeArts pipeline, enabling standard deployments, environments, and implementing automated deployments. It helps to reduce costs and increase release efficiency. There are two types of development methods, host deployments and container deployments. In host deployments, we install the applications on virtual machines. That is on the ECS service in Huawei Cloud. In container deployments, we use the Cloud Container Engine service. Deployments can be done manually through CodeArts Artifact, or we can save it to image repository and it from there. Of course, we have image repository as SWR. After deployment, we need to test. So, CodeArts Test Plan, a cloud testing platform for software developers. It provides manual or automated API testing. Its goal is to ensure the development of high quality, bug-free products. There are various sub-services under CodeArts Test Plan, such as test design, test case, test execution, and quality report. And we have now pipeline. The CodeArts pipeline provides us with continuous integration and continuous deployment software pipelines, which we can call CI/CD, which can be organized and visualized. It reduces lead time and increases efficiency. CodeArts pipeline allows us to add, edit, slime, and organize tasks at the steps in the pipeline and present them in a visual way. Now we have a performance test. It helps you simulate user loads. You can test how your app performs with different numbers of users, identifying any potential bottlenecks before they affect your real users. Also, you can use stress tests, push your application to its limits, and see how it behaves under extreme conditions. This helps you understand how it fail and recover. Also, you can monitor in real time. As you test, you can see performance metrics live, allowing you to catch issues on the spot. Integrate with CI/CD. It fits right into your development pipeline, making performance testing a seamless part of your workflow. Why do we use performance tests? By using CodeArts, you can catch problems early, improve the quality of your application, and ultimately provide a better experience for users. In short, it's a fantastic way to make sure your applications can handle whatever comes their way. Uh, Thanks for listening my presentation. If you have any question, you can ask me, or we can continue with the demo part of our project. Let me open the Huawei Cloud. Okay. Now we are in Huawei Cloud console part. Um, Zeynep, can we change the page, please? Thank you. Okay, now we have a Huawei Cloud console part, and we can list all services from here. Let's open the CodeArts. Oh, sorry. I shared wrongly. Share screen, like window. Okay. So that's my fault. By the way, you can use the CodeArts freely, and it's a free service. So in that way, you can you can use the repository for your source code. You can take a build in our service freely, and you can continue with it. See if you can share it again. Sorry. Okay, thank you. In the CodeArts page, we have we can list all projects in here. And today I will gonna create a project. In this demo, we will build and deploy the ready example project. We're gonna work on it. Let's write here TTT training. Okay. Now we have in a project, we are in a project, and as you see, we have a repository. All of our source codes are listing in here. Let's wait to open it. Okay, this is the example sample project source code. So let's look at it in the repository. As you see, all of my project is in here, and I can open the my coding programs. For example, I open the YAML file. It's showing in here, and I can edit it. I can write anything I want and sending a commit message, but I will not change it for now. Also, I have a check, code check. With code check, I can start a task on our repository or source code, and I will see the security ambience and errors in my code. So as you see, there are lots of tasks in here. Let's open the worker part. Issues, metrics, settings. In settings, there are rule sets. You can add any rule set as you want, or there are ready languages, and I can add some languages in here, such as Python. I can open the Python, and now I can start check, for example. As you see, it's starting to executing, but I will continue with the build part. When you take your projects taking to build, you should add some settings in the build task, such as if you create an image, you will add the repository address of SWR. So let's continue with it today. Okay, in taking build in for example CI, we should add some parameters. In these parameters, we should add some organization name and Docker server. For that, we will open the SWR. In SWR, we can create an organization in here. I can write it here, DTT. Okay. As you see, I created the organization and I can list it in here. Only I have a permission and access to images. After that, I will take the login command for accessing to send image. I'm taking the address link in here and I'm writing in here. And also I will show it in build actions. It's taking the build image and push it to SWR and our organization name Docker.org in here. So in parameters, we will write it here as name, DTT. So we can also schedule the build task. We can see the history of the change. We can change the accessing permission, but after all, we don't change them. We will just start the build. Okay, it will take the build part. All steps will be done, and while it's doing that, let's look at the some testings. We can create a test plan in here. So it's a sample test plan. It's a example, and we will gonna run this test plan after deploying. It will not gonna work before it, so I will just gonna show it for now. There is a test design. It's for the advanced plan. For free using, we cannot showing test design. So also there is a test case. You can prepare and write here some cases. For example, adding offer as an administrator is a test plan, test case, sorry, or homepage test, the data analysis test. All of them are cases, and we can start the operations in here, or we can just show it as a completed, successfully completed, failed, or etc. Also, we have execution testing, and after all these steps, there are quality reports and quality assessments. But now let's get the build part. Let's get, is it done or not? Okay, it's taking the build continuously. After the taking build, we're gonna access to all packages in release repos. So we used Maven in this project, and it became a package and sending to as an image to SWR. So we can examine the all project, all package in the release repos, and we can see that. And let's look at the results of the code check. It's, as you see, it's passed because our project is writing as Java and Python. So we have 5 issues, but these are minor issue, as you see, not critical or not major. So that's why it's passed. These 5 minor issue is listing in here, and it's explaining to what's the issue, and you can solve these problems. We can set the metrics in here, and we can see the logs in this page. So build should be done. Yes, as you see, we take the build part, and we can see the results of the builds in release repos. Here we have YAML files, all for our projects. And we have Docker stack files as tar.js. These are packages for our project, and we will gonna deploy them from the SWR image. Let's get the SWR. As you see, 5 image is came to this organization, and we can see the images in here. So after that, we can set some triggers or pull to push projects, but we will not gonna have these problems in here. We're gonna do the deploying parts, but before the deploying parts, we will create a virtual machine. What was our virtual machine? ECS, Elastic Cloud Server. So we will create a ECS. So we will buy a virtual machine, and we will deploy the project in ECS. So AZ can be random. It's a data center. So in a region, we can have more than one AZ. So each AZ means that there are 4 data centers. And in the instance, we will buy some strong one, but you can buy the cheapest one, such as in general computing. You can have 2 to 2. That's a cheap one. But I'm not suggesting the one-to-one. Today in the training, we will gonna use a strong one. Let's take the 8 to 16. In public image, we will gonna use Ubuntu, and I will select the 16 version. It can be SSD. Let's select the VPC. Okay. Let's select the security group. In security group, we are setting the ports settings. We are opening the working ports and open to some IP addresses, or close some IP addresses. So I will open the this project's ports. That's why I choose my security group. We need to EIP. We were gonna use the traffic parts. In traffic, we will pay the EIP traffic price as per gigabyte, but in bandwidth, we will gonna pay it per hour. So that's why I'm buying the traffic parts, because we will not gonna use it as 1 gigabyte. And bandwidth size is not important in the traffic part. Okay, let's give a name. Okay, let's give a password. Okay, and our username is root. I am a IAM user, so that's why I'm selecting the enterprise project, and I wanted to delete this virtual machine after the training, so that's why I'm setting some settings in here. 15, 17, 15 is enough. Okay. Today at a 5:15, it will delete it. So let's create a virtual machine. Let's back to the ECS list. Okay, it's creating right now, but it will create it in a minute. Let's put if you have a question, you don't. Okay, let's continue. Okay, as you see, it's running, so it's working. Let's define the project in CodeArts in the settings, and after that, we will deploy the project. As you see in the settings, general settings, we have basic resources. In basic resources, we're gonna define our virtual machine to deploying. Let's create a host cluster. I'm giving the name of DTT host. I will gonna choose the Linux because I'm using the Ubuntu, and I will not gonna use the proxy because I don't need the security for training, and it will gonna be more faster. So let's click save, and after creating the cluster host cluster, we're gonna add a host. In Huawei, we can add the host as clicking the import. When I click the import, it will gonna add it, but also we can adding a IP. In that way, if you have a server in your home, in your company, or in your school, you can edit here hostname, giving these servers IP addresses, and after that, you should just enter the login languages. But we will not gonna do that for now. We're gonna just select our ECS. As you see, name and IP is automatically is written in here. After that, I will gonna just give my username, my password, and my SSH port. After that, as you see, it's added and trained to verifying. Okay, we successfully add our virtual machine in the CodeArts. So when I deploying, CodeArts know that this virtual machine should use in deploying part. So I will gonna add it in our deployment part. Here we have pre-deploy part. In pre-deploy part, we will gonna install the Docker and necessary libraries in our project. In the deployment part, we should add environment. In environment, we will define our virtual machine. We defined our virtual machine in CodeArts, but not in deployment part. So I'm selecting my virtual machine in here, import it, and it's successfully verified. So we have an environment in here. And in the actions part, I'm selecting the environment, and our virtual machine is defined successfully. So we don't have any changes to here. We just install the Docker. I will use version 19, and we have shell commands in here for the libraries. So let's click the save and deploy. Okay, it will install the Docker and it will install the all our libraries. It will take a couple minutes only, so we can wait it here shortly. So let's say that if you have any questions, you can ask me in that way. Okay, I guess you don't have any questions. Pre-deployment part is done successfully. We installed Docker, but how can we sure? Let's be sure. Is it installed or not? I will connect to our virtual machine remotely. Now I'm in a virtual machine as Ubuntu. I will enter my username. I will enter my password and successfully I logged in. As you see, our Docker version is 19 and it's installed successfully. So after that, we can start the deployment our project in this virtual machine. Let's continue with the standalone part. I will click to edit. And that way, first of all, we should define our virtual machine in this deployment too, because other deployment know that your virtual machine, but this deployment doesn't know. So you should define it as environment. And the actions part, we will select the environment. And I will choose the build task. After that, we don't have any changes in actions part. We should add parameters as the SWR login temporary. So we will gonna take them in the SWR page, software repository for container page. I will take my login command in here. After you, this is our username. I'll copy it. Okay. And after P, it's our password. Be careful. There should be no blank space. Sorry, I didn't copy it. Okay, there should be no this blank space as you see. I will delete it. And this is our address. You learn it before that. Okay. After that, we can click the save and deploy. Okay. When it's deploying the project, actually it's deploying very fastly because we bought a strong instance, and this instance can take the actions very fastly. So it will done in a second. Now let's the question. There is no question. Okay. In the service, we can have the Devops parts. and we can do some tests and getting experience in these services. So as you see, our project is done and successfully deployed. Let's look the deployment. This is our EIP, Internet IP, and this is our private IP. So we're gonna use the internet access. So I'm taking the EIP. Let's write into project as like that. I'm adding the 5000 port. And as you see, I access our e-commerce website. I can buy some battery, brake pads, air filter, etc. This is the customer page of our projects. And when I click to 5001, I can access the admin part. As you see, this is the admin part. I can see the matrices, most popular products, categories, parts, special offers, etc. Actually, this is our project, and we successfully deployed the internet. And after that, lastly, we can look the members parts. After that, we should look the pipeline, and we will finish the training. Let's get the members. We can add project members from here by clicking the add members or invite via link. When I click the via link, it will be there is a QR and URL. When I share this QR or URL, people can join my project, and I can give permissions to them, such as project manager, system engineer, or tester. As you see, tester doesn't have a permission to access the repository, but in the test plan, tester have permissions, as you see. Also, in general, we can add some endpoints, such as okay, it's open. Such as our code check from the outside, or Jira, etc., or Jenkins endpoint. We can create and add it. Also, we can manage our project from the pipeline. We can continue with workflow. No. Let's click the edit. As you see, we have a source, code source. We have build and deployment parts. Let's delete the CC and edit here. Let's choose the deploy parts. Add it here as standalone. Okay. Sorry. Standalone. As here. Let's create it. Let's edit here as pre-deploy. Okay. Let's change the place and his name pre-deploy. Okay. As you see, you can change the place and add some For example, check. Okay, we can add a check part. What was it? As I remember, worker. Full okay. We can change the place of the check, or we can put it in here. This is our pipeline, and when I click the save and execute, I can change only build and deploy parts or only build parts, but I will choose all of them and clicking to execute. As you see, it started and it will continue to step by step, and it will access to end successfully. Today, we learned that Devops we learn other some models like waterfall, agile, and we're learning the CodeArts theoretically and practically. We deployed our project to internet, as here, and now you can use the CodeArts service freely in your own user account. I'm suggesting to use it, and if you have a question, don't be shy. Please ask it, or you can ask me on the LinkedIn. After all, thank you for listening. Actually, we can finish the lesson for now. If you have any question, you can ask me. Okay, after that, let's finish the lesson. See you guys. Have a good day.